Last week, we proved a lot of things that were true about all parallelograms. We proved that their opposite sides had to be congruent. We proved that their opposite angles had to be congruent. We proved that their consecutive angles had to be supplementary to each other. And we proved that their diagonals bisect each other. That's a lot to say about parallelograms. We can be even more specific when we're talking about special kinds of parallelograms, like rectangles and rhombuses and squares. This video, we're going to look at the rectangle. So the cool thing, and this is based on the work we were doing last week, we know that every rectangle is a parallelogram. So when it comes to the facts we know about rectangles, everything that we know about a parallelogram also has to be true about a rectangle. So everything that I just talked about in the last video, in the last week's videos, and in that short list are going to be true of rectangles as well. But since we've got these 4 right angles, we can say something a little bit extra. And so one of the extra things we can say is what we're going to prove right here. So given that this is a rectangle, these 2 diagonals are going to be congruent to each other. That isn't true for most parallelograms, but it is true for rectangles. Okay, so let's prove this. So I've got my flowchart proof kind of set up here. I know that I'm given that we have a rectangle, and there's a whole lot of facts that come out of that. I don't know what's going to be important yet, though. But I know that my goal is to prove that AC is congruent to BD. So let me highlight those in different colors in my diagram, and that might help me to think about how I can prove that these 2 things are congruent. The one trick that I know in geometry that we've used over and over to prove that line segments are congruent is that if we can prove that these are corresponding parts of 2 congruent triangles, then we're all set. So can you see 2 triangles in this diagram, one of which has this diagonal as a side and the other one has the yellow diagonal as a side, that would have to be congruent to each other? All right, and so here's what I see. So if I can prove that that yellow triangle is congruent to this pink triangle, then I could get to the bottom step by CP/CTC. All right, so let's make that the second to last statement of our proof. Triangle ABC is congruent. This goes along the bottom side to the right angle to the top. So for the yellow triangle, starting from the far side, going along the bottom, B to A and up to D. Remember, when you do triangle congruence, you need the corresponding vertices to line up. All right, and if we found some way to prove that that's true, then this is going to be true because of CP/CTC. So let's look at this and see if we can come up with 3 pieces of evidence based on just given that the quadrilateral is a rectangle. Well, the first thing we know is since it's a rectangle, because of the definition, those have to be right angles. All right, so that's a consequence of the fact that this is a rectangle. So I'm going to say angle BAD and angle ABC are right angles. And what's going to be my reason for that? I just used the definition of a rectangle. Okay, a rectangle is a parallelogram where all 4 sides are right angles. And because of that, I can say that angle BAD is congruent to angle ABC. Can you think of what the reason for this step is going to be? Knowing that these 2 are right angles, how can I tell they're congruent? That's because all right angles are congruent. Notice how I'm kind of using some symbolic abbreviation. So that's angle. This is the congruent symbol. All right. So I just proved that these two angles are congruent. What else do I know about those two triangles as far as corresponding parts being congruent about them? Well, some people might be shouting out that side right there. So that side is going to be congruent to itself because that's in both of the triangles. So AB is congruent to AB. And what's the reason we give when we say that two things are congruent, and something is congruent to itself? It's like a reflection. So we call that the reflexive property. All right. And what's the third part of these triangles? Well, I don't know anything about the acute angles of this, but again, since ABCD is a rectangle, I know that the height of the rectangle is the same. So AD has got to be congruent to BC. And the reason for that is that this is a rectangle. Again, we're using the fact that this is a rectangle and all rectangles are parallelograms. And we showed last week that the opposite sides of parallelograms are congruent. Sides of parallelogram, and I'll just draw a picture of a parallelogram, are congruent. And if you're using a T-chart to do your proofs, you don't have to worry about arrows. But again, we're taking, this is only true because we know that this is a rectangle. So I need an arrow pointing from here to here. Reflexive property, that doesn't care that this is a rectangle. AB is congruent to AB no matter what. And so now we've got three pieces of evidence that fit into our congruent triangle statement. So ignoring the yellow triangle for a minute, look at that and figure out which one of the triangle congruence theorems we're using to prove that a triangle with this evidence is congruent to another triangle with the corresponding set of evidence. Well, you might be thinking that this is HL because we've got a right angle here. This is a right triangle, so we could use HL. But remember, the H stands for hypotenuse, and we don't know anything about the hypotenuse of this triangle. So we're not going to take advantage of the fact that this is a right angle, but it's an ordinary angle. So what we have are two sides and the angle that's between them. Two sides and the angle that's between them. And again, in the yellow triangle, just to be clear, we've got two sides and the angle between them. And so our reason is going to be two S's with an A between them, the SAS theorem. Okay, so let's review this really quickly. Since this is a rectangle, we know that the opposite sides have to be congruent. And we know that the right angles, the vertices of the rectangle are right angles. And since all right angles are congruent, we've got a congruent angle there. The third thing came from the reflexive property. That let us say that the yellow triangle is congruent to the pink triangle. And therefore, the diagonals of the rectangle have to be congruent to each other. So that's a new fact we have about rectangles. And so I'll jump back to the document camera and put that into our chart. Diagonals are congruent. So we're starting to fill out the form by figuring out some extra things that are true about rectangles.